Right now, I want you to picture stepping onto a bathroom scale. You look down and it shows a number. Let's say it's 70 kilograms. That number feels like a fact about you. Solid, permanent. Something true about who you are, as real as your height or the color of your eyes. But here's the secret almost nobody stops to think about. That number is one of the least permanent things about you in the entire universe. Because if you carried that exact same scale to another world and stepped on it there, the number would change dramatically. On the moon, you'd suddenly weigh a fraction of what you do now. On Mercury, that 70 kilograms would drop to just 26.5. And on one particular place in our solar system, you would weigh nearly 2 tons, crushed instantly by your own body. The strange truth is this: your weight is not really about you at all. It's about where you're standing, and once you understand why, you'll never look at that number on the scale the same way again. So let's take a journey. Let's carry our scale across the entire solar system and watch the number swing wildly at every stop. But before we take a single step, we have to clear up the most important idea in this whole story. Because there's a difference between two words that most people use as if they mean the same thing. They don't. Those words are mass and weight. And the difference between them is the key to everything. Your mass is the amount of stuff you're made of. All your bones, your muscles, your blood, every atom in your body added up. And here is the crucial part. Your mass does not change no matter where you go. 70 kilograms of you is 70 kilograms of you on Earth, on the moon, on Mars, floating in deep space, anywhere. The amount of you is constant across the entire cosmos. Your weight is something completely different. Weight is simply how hard gravity is pulling on that mass. And gravity is not the same everywhere. So when we say you'd weigh 26 kilograms on Mercury, what we really mean is this. Your body would still contain the same 70 kilograms of stuff, but Mercury's gravity would pull on it so gently that a scale would only register the pull of 26.5. You wouldn't lose a single atom. You'd just feel lighter, because the world beneath you is tugging at you with a weaker hand. Hold on to that, because it changes the meaning of every number we're about to explore. Now, the obvious question is, what decides how hard a planet pulls? Why is gravity strong on some worlds and weak on others? And most people assume the answer is simple: bigger planet, stronger gravity. But that assumption is wrong, and the ways it's wrong are some of the most surprising facts in all of astronomy. Two things decide a world's surface gravity. The first is how much mass the world has, how much total stuff it's made of. The second is how close you can get to its center. A planet that packs its mass into a small, dense ball can pull on your feet surprisingly hard because you're standing close to all that concentrated matter. And a planet that spreads its mass out into a huge, puffy ball can pull surprisingly gently because you're standing far from its heart. So size alone lies to you. To really know your weight, you have to know both how heavy a world is and how tightly it's packed. Let's start our journey somewhere humans have actually been. The moon. When the astronauts walked on the lunar surface, you probably noticed how they moved, bouncing, floating, taking those slow, gentle, loping hops. That wasn't because of clumsy spacesuits, that was gravity. The moon's gravity is only about 1/6 of Earth's, so our 70-kilogram traveler standing on the moon would weigh only about 11.5 kilograms on the scale. Imagine that. You could leap into the air and hang there far longer than you ever could on Earth. Lift objects that would pin you to the ground back home. On the moon, you'd feel almost like you could fly, and yet your body is exactly the same 70 kilograms of you. The moon simply holds you with a lighter grip. Now let's travel inward, toward the sun, and visit the smallest planet, Mercury. This is the one from our title. Mercury is tiny, barely bigger than our own moon, and here's where you'd expect its gravity to be almost nothing, but Mercury has a secret. It is extraordinarily dense. Deep inside it holds an enormous metal core packing a lot of mass into a small space. So despite being one of the smallest planets, Mercury pulls with more strength than you'd guess. On Mercury, our 70-kilogram traveler would weigh about 26.5 kilograms. And now for one of the great surprises of the solar system. Let's jump to Mars, the red planet, which is significantly larger than Mercury. You'd expect Mars to pull much harder, right? It's a bigger world, but it doesn't. On Mars, that same person would weigh about 26.5 kilograms too, almost exactly the same as tiny Mercury. How is that possible? Because Mars, though larger, is far less dense. Mercury makes up for its small size with its heavy packed interior. Big, fluffy Mars and small, dense Mercury end up pulling with nearly identical strength. It's the perfect proof that size alone tells you nothing. Let's keep going. Venus is often called Earth's twin, and when it comes to gravity, the nickname fits. Venus is almost the same size and mass as our planet. So on Venus, our traveler would weigh about 63.5 kilograms, just a little less than on Earth. If you could somehow survive its crushing, boiling surface, your weight would feel almost normal. Now we head out to the giants, and this is where the real surprises begin. Let's go to Saturn, the great ringed planet. Saturn is the second largest planet in the entire solar system, a colossal ball so vast that over 700 Earths could fit inside it. Surely on a world that enormous, you'd be crushed with gravity, weighing many times your Earth weight. So brace yourself for the answer. On Saturn, our 70-kilogram traveler would weigh about 74.5 kilograms, barely more than on Earth. Let that sink in. The second biggest planet in the solar system has almost the same surface gravity as our own, and the reason is one of the most delightful facts in astronomy. Saturn is unbelievably light for its size. It's made mostly of gas, so puffed up and spread out that its overall density is less than water. If you could find a bathtub big enough, Saturn would actually float. So even though it holds a huge amount of mass, that mass is spread across such an enormous volume that standing at its cloud tops, you're incredibly far from its center. And so it barely pulls harder than Earth. And it gets stranger still. Let's visit Uranus, another giant, far larger than Earth. You would think once again that a giant means heavy weight. But on Uranus, our traveler would weigh about 62 kilograms, which means you would actually weigh less on the giant planet Uranus than you do on Earth. A world you could fit 60 Earths inside, pulling on you more gently than your own backyard. Neptune, its cold blue neighbor, is a bit denser, and there you'd weigh around 80 kilograms, noticeably more than on Earth, but still nothing extreme. Now I have to pause and be honest about something, because it matters. Saturn, Uranus and Neptune don't actually have solid surfaces to stand on. They're balls of gas and liquid, so these weights are what you'd feel at the level of their cloud tops, the outer edge where the atmosphere begins. You couldn't truly stand there, but the numbers still reveal the true strength of each world's pull, and that's what we're chasing. But there is one giant that lives up to its reputation: Jupiter, the king of the planets. The largest, most massive world in our solar system by far, more than twice as massive as all the other planets combined. And unlike puffy Saturn, Jupiter's immense mass pulls with real force. At Jupiter's cloud tops, our 70-kilogram traveler would weigh about 177 kilograms. Suddenly, everything is different. You'd feel more than 2.5 times heavier than on Earth. Lifting your own arm would be a struggle. Standing would exhaust you. Your body, built for Earth's gentle pull, would feel like it was drowning in its own weight. Jupiter is the one giant that truly tries to crush you. And now, for contrast, let's go all the way to the opposite extreme. Out to the cold, distant edge of the solar system to Pluto. Pluto is tiny, smaller even than our moon, and far from any concentrated mass. So its gravity is feather-light. On Pluto, our 70-kilogram traveler would weigh just 4.5 kilograms. About the weight of a house cat, you could jump and rise many meters into the air, drifting back down as slowly as a falling leaf. On Pluto, you would be lighter than you have ever been anywhere. But we've saved the most extreme place for last, because there is one object in our solar system whose gravity dwarfs every planet combined: the Sun. The Sun holds more than 99% of all the mass in the entire solar system. It is a titan, beyond anything else out there, and its gravity reflects that. If you could somehow stand on its surface without instantly being vaporized, our 70-kilogram traveler would weigh nearly 2,000 kilograms, almost 2 tons. Your body, the same 70 kilograms of stuff it has always been, would be pinned down by a force so brutal that your own muscles could never lift you. You couldn't stand. You couldn't breathe. You couldn't even move your chest. The Sun's pull is so overwhelming that a human body simply could not hold itself together against it. So let's come back home, back to that bathroom scale, and look at what we've really discovered. We watched one single person, unchanged the entire time, step onto the scale across the whole solar system. 11 kilograms on the Moon, 26 on Mercury and Mars, 63 on Venus, 177 on Jupiter, 4.5 on Pluto, nearly 2 tons on the Sun, 6 wildly different numbers. And yet, through all of it, that person never gained or lost a single atom. Their mass, the true amount of who they are, stayed exactly the same at every single stop. Only the pull of each world changed, and there's something quietly beautiful hidden in that. The number on the scale, the one so many of us worry about, obsess over, let define how we feel about ourselves, turns out to be one of the most arbitrary numbers in existence. It isn't really a measure of you at all. It's a measure of the ground beneath your feet. Change the world you're standing on, and the number changes completely. But the real you, the actual substance of who you are, is a constant. It travels unchanged across the Moon, across Mars, across the crushing surface of the Sun. It is the same everywhere in the universe. So the next time you step on a scale and see that number stare back at you, remember what it actually is. Not a verdict, not a truth about your worth, just a quiet conversation between your body and the particular rock you happen to be standing on. Carry yourself to another world, and the number bends and shifts like a shadow. But the thing casting that shadow, the real, constant, unchangeable amount of you, remains exactly what it always was, and that no planet in the solar system can ever change.